Hello and welcome to the application number 7 walkthrough. Today we're just going to look at a quick little video that can help you sort of get an idea on how to do the application problems. We're not going to do all the problems, and even some of those that we do we may not do to completion, but at least to get you started and in the right direction. So for starters, on these two problems, it does say to solve them. There's really no solving that can be done on these problems. They are factor problems. And I'm going to say on these, we want to factor the greatest common factor, or GCF. So we're looking at what could be in these that we can then pull out in front. Anytime you have a bunch of variables like this, I'm not frequently going to ask you to take that many variables and come up with, do our binomial factoring where we, like our bottoms up method. I'm not going to ask you to do that. So looking at this problem, the first thing that I notice is, the numbers. Okay, the numbers are the first thing I'm looking at. And they're all multiples of 9. So 72 is 9 times 8. Another 9 times 8 there. And this is a 9 times 7. So I know that I have a common factor of 9 in each one of those. I'm going to go ahead and pull that out in front. So I do that, and then I want to look at, before I write my parentheses, I want to look at my variables. I guess I'll just rewrite that whole thing. So I know that I'm going to be pulling out a 9. Do I have x's in every term? I do. I have 1 here. I have 2 x's here and 3 x's here. So I can pull out 1x. Do I have y's in every term? I have 2 y's here. I don't have any, and I don't have any. So I don't get to pull out any y's. And then what about z's? I have 2 z's, 3 z's, 1 z. So I get to pull out 1 z. Okay, that's what I'm factoring out. Now let's rewrite this with what I have left in each term. So in this one I have an 8. And then I pulled out 1x and 1z. So my x goes away, and I am just left with z to the first power, which we just write as z. And then we have still our y squared in there. And then we have a minus, and it's going to be a minus 8 again. And then what about so I pulled out 1x and 1z. So I'm going to have x and z squared left over. And there we go. And then out of my last one, I pulled out a 9, so I'm left with 7. Pulled out 1x, and then I pulled out my only z, so I'm just left with x squared. And again, I'm not going to ask you to do our binomial factoring on a problem like this. I don't want to do that. This is actually a pretty complicated problem to do that, especially with the variables the way they are. Okay, I'm going to leave you to do number 2. It's pretty much the same. I want you to factor out the GCF, or the greatest common factor that you can find, and it shouldn't be too bad. Okay. All right, let's look at number 3, because number 3 is, one of those word problems. So sometimes people get a little bit concerned with word problems. So I know that I have a painting here, and the area is x squared plus 50x. And looking at that, I know that I could factor out a greatest common factor out of there. Both of those have a spare x. Okay, both those terms have a spare x. And so I'm left with x plus 50. And again, that's the area. And it's the area of a rectangle. And the area of a rectangle is length times width. So in order to have found that area, I would have had to take the length and multiply it by the width. Well, they tell me that the width is x. Well, that could be seen as this x right here. Okay, So realistically, this is like width times length. So what that's telling me is what's left over to be the length. What's the other thing I'm multiplying by? It's this x plus 50. So this measurement here for length is going to be x plus 50. And there we go. That's it. I know it seems like a tough problem, but it's really not. Number 4 over here says amount on an investment. So the amount of an investment of P dollars for T years is with a simple interest rate R. Okay, I'm going to do part A here and let you figure out part B. But it's given by the principal plus the principal times the rate times the time. So we want to rewrite this for A being the amount in the investment. And I want to factor out a P. I want to factor out the principal amount. Okay. So factoring a P out of this first one, well, that's the only thing there, so I'm left with 1. Factoring a P out of the second one, I'm just left with RT. And that's a more common formula for this because it's a little bit simpler. All right, you don't have to put your principal amount in there twice. Okay, you just have to put it in there once. Now, the principal amount, and this is important for the next problem, the principal, the P, is the amount invested. Okay, that's the amount you put in. Okay, so if you want to start an investment, which isn't a bad call, well, let's not call it put in, let's call it like, it's similar to like a down payment. So the amount that you risk, maybe that's a better analogy. So that's like my down payment. In the problem below, it's the amount that you invest. Okay, so this is that P right here. The 1 is just a 1, nothing to worry about there. The rate, okay, interest rates are always given as percent. The important thing here is that you have to plug this in as a decimal. So you have to plug that in as a decimal. Okay. And then the time can really be any amount of time, and it's dependent on the rate. This interest rate is a per year interest rate, and we're wondering about 3 years. So this time is just going to be your number of years. And I get a lot of students asking, well, do I have to do any conversions from years to any other unit of measurement? And no, you don't. You're given years, plug in years, because it didn't really say it, but this 15% interest rate is a yearly interest rate. Okay, so that being said, you can then plug in the values that you have down below into this formula and figure out what that investment would be worth after 3 years. Okay. Down below, the next problems, they're all about binomial factoring. So just be thinking about that. This is like the second half of what we covered. So this is binomial factoring, meaning I want to turn 3 things into my 2 sets of parentheses. Okay. And the first one, I know it looks a little bit difficult, but I think we can figure it out. Okay. And almost figure it out a little bit backwards, not really bottoms up per se. I want to know what happens if, for instance, I kind of just want to know what two things would I multiply together to give me this result. And this is kind of the best way that I can approach this problem with the skills that we have. Um, we could try bottoms up and that would be okay, but we don't really have like A's and C's and things like that. It's a little bit difficult to think of it that way because like technically here my C is y squared, so that's a little bit tough. Um, so looking at this, what happens if I know I have x's and y's, so I'm going to have x's and y's involved here. What if I have two x plus y's? What's going to happen if I try to FOIL those? So this is kind of a working backwards idea, but what happens if I FOIL those? I get x times x, which is x squared, x times y, which we just write as xy, y times x, which we can also write as xy, and y times y, which is y squared. And now if we combine my terms here, I have one xy here and I have another xy here. When I add those two together, I will get two xy's. And plus my y squared. So in the end, I mean, we didn't really factor it per se, but we figured out what the two factors would be, and it's x plus y times x plus y, which you may also see written as, or we saw it earlier, x plus y squared. Number 6 is quite a bit easier. Think about that one a little bit. And you can turn that into two sets of two parentheses. Okay. It has something to do with the fact that both of those are squared and that there's subtraction here. That's a huge key to this. Some of these, or number 7 at least, it's a find the area problem. It's a multiplication problem. It's not a factoring problem. Okay, you don't have to factor this. Just multiply your length and your width. Okay. Then on number 8, that one is a factoring problem, and I'm going to leave that for you. You're going to have to do bottoms up, where your first step ends up going x squared minus 5x minus 24. Okay. And then work that out, find your two factors, and remember that you're going to divide your constants by 2. You're going to find your two things in there and divide them by 2 to figure out, or to undo what we just did. So that being said, I think you have enough tools at this point to go ahead and complete this application. If you have questions, feel free to ask them either in the comments or when I get back into class next week. Okay. Not a great scenario with me having to be gone right after you guys are gone, but the biggest thing, feel free to ask questions in the comments. I know it's kind of hard to type math questions, but do your best, and I'm going to stay on top of answering the questions and try to help you out, because I don't want you to fall behind, and we are moving forward through some kind of more difficult stuff, so be ready for that. Good luck. We'll see you when we see you.